Hello. In this video, we will learn about what vector subtraction is, what it means, and how to use it. We will also learn how it is useful for determining the relative position between two objects. It is also useful for determining the relative velocity between two objects, which will make more sense later. This video assumes you know what vector addition is. If you don't, then go back and see that video, please. First, let's look at what vector subtraction means when we think of vectors as arrows. Here we have two vectors, u and v, and we want to know what happens if we say u minus v. If this were addition, we would take our u vector and place it anywhere. Then we would take our v vector and place its tail at the head of the u vector. The resulting vector is the vector that stretches from the tail of u to the head of v. However, in vector subtraction, we do something different. We completely flip the v vector, since that is the vector with a negative sign in front of it. We then draw the vector from the tail of u to the head of v, and that is our resulting vector. In fact, you can really just think of vector subtraction as vector addition, except you are adding a negative vector. A negative vector just flips the vector so that it faces the opposite way. That is because when you multiply -1 by each component of the vector, you flip each component. So with that in mind, let's actually compute the vector here. We will take the x component of u, which is 5, and subtract it by the x component of v, which is 3. So our resulting x component is 2. Next, we will take the y component of u, which is 2, and subtract it by 4, which is the y component of v. This results in a y component of -2. So our resulting w vector is given by 2, minus 2. So let's use vector subtraction to determine relative positions. What does that mean? Well, imagine I have some kind of technology that tells me where I am relative to a cell tower. Perhaps it is telling me that my position vector from that tower is 20, minus 40 meters. And let's say you are using the same thing, and you are told that you are at a position vector that is 30, 30 meters from the tower. Now, if I wanted to come find you, what direction should I walk, and how far will it be? If I could get a position vector that points from me to you, I would have that information. This is what I've called a relative position. I want to know your position relative to where I am. To do this, we use vector subtraction. I take r sub y, which means your position, since y stands for you, and I subtract it by r sub m, which means my position, since m stands for me. This will equal r sub ym, which means your position relative to where I am. The rule to keep in mind is that the vector will point from the position that has a negative in front of it towards the position that is positive. In this case, that means it will point from me towards you, which is exactly what we want. So let's work with the numbers given. Let's find the x component first. 30 minus 20 is 10 meters. Next, the y component. 30 minus -40 equals 70. So the relative position vector that points from me to you is given by 10, 70 meters. If we wanted to know the vector that points from you towards me, then we would flip the order of subtraction, and the result would be minus 10, minus 70, a vector that points in the exact opposite direction. Now, to connect this back to something you might have learned earlier, we could add little o subscripts to this equation, where o means the origin, or the tower in this case. This tells us that the position vectors we are given for my position and your position are relative to the origin, which is the tower. If you already learned how to work with relative values from a previous lesson, then you can look at this equation and understand how we got it. Now, we are going to do something very similar, but this time we will compute the relative velocities between two objects. To explain what that means, let's look at an example. Imagine we have two airplanes flying into an airport at the same time. From the perspective of someone standing on the ground and not moving, airplane A has a velocity of 100, minus 20 meters per second. Airplane B has a velocity of minus 75, minus 20 meters per second. Now, we might want to know, from the perspective of airplane B, what does it look like airplane A's velocity is? That means that airplane B considers themselves to not be moving at all. Rather, airplane A is moving, as is the ground beneath airplane B. Whenever we talk about relative motion from someone's perspective, we mean that, from his perspective, he is not moving. Everything else is. So, to get the relative velocity of A from the perspective of B, we need to subtract the velocity of B from the velocity of A. Let's work out the numbers. First, the x component. 100 minus -75 is 175. For the y component, -20 minus -20 is 0. So that leaves us with a velocity of 175, 0 meters per second. Uh-oh, that's a direct collision course. From airplane B's perspective, she is not moving, but airplane A is hurtling directly towards her. So now you have learned how to do vector subtraction and how to apply it to finding the relative position and velocity.